Learn about the benefits of using Ganache for blockchain development, including a personal Ethereum blockchain network and a user-friendly interface. Programming languages like Solidity, which is used to build smart contracts on the Ethereum blockchain network, are frequently used in blockchain development. Ganache helps developers test and debug their applications before deploying them on a live blockchain network. Also, developers must be well-versed in blockchain technology, including its underlying architecture and concepts like consensus algorithms, cryptography, and decentralized governance. This article will discuss what Ganache is and how you can use it in decentralized application (DApp) development. Ganache is a software tool developers widely use to create a local blockchain network for testing and development purposes. Developers may effectively test different scenarios and troubleshoot their blockchain apps by simulating a blockchain network on their local PC with Ganache. Ganache supports the quick development of distributed applications using Ethereum and Filecoin. The tool is first installed on the developer's computer, and a new workspace must be created before using Ganache for blockchain project development. Developers can link their blockchain project to Ganache once the workspace has been built, enabling them to test and debug their application on the simulated blockchain network. Ganache provides a range of useful features, including the creation of new accounts, the ability to send transactions, and the capability to debug smart contracts. By effectively locating and fixing bugs in their smart contract code, developers can use Ganache as a debugging tool to speed up the development process. The debugger feature allows developers to comb through their code line by line and see the values of variables at each step, making it easier to find and fix bugs. Two versions of Ganache are available, a user interface (UI) and a command line interface (CLI). Thanks to the user-friendly Ganache UI, developers can quickly communicate with the local blockchain. In addition to offering real-time data on accounts, balances, transactions and events, it also has tools for testing and debugging smart contracts. In addition, the interface includes a built-in block explorer tool that lets users examine the specifics of each block and transaction. On the other hand, developers can communicate with the local blockchain via the terminal using the Ganache CLI. It is a more versatile and compact choice for people who prefer using command line tools. Developers may automate testing and deployment operations by integrating the CLI with other development tools and scripts. Regardless, the essential functionality of the Ganache UI and CLI is the same, and developers can choose the version that best suits their tastes and workflow. Yes, Ganache is a free, open-source blockchain development tool. The personal blockchain network can be launched and managed using Ganache's user-friendly interface. To make it simple for developers to test their smart contracts in a secure environment, it also produces private keys for the accounts generated in the network. In the Ethereum development community, Ganache is a popular tool for creating, evaluating, and deploying smart contracts. It is ideal for developers to incorporate it into their workflows because it is interoperable with other Ethereum development tools like the Truffle Suite framework. Truffle Suite is an Ethereum development framework for building, testing, and deploying smart contracts on the blockchain. Truffle and Ganache are not the same blockchains, but they are closely related tools used in blockchain development. Truffle can be used with various blockchain networks, but as a local development network, it is most often used with Ganache. Before releasing their smart contracts to a live network, developers can use Truffle to design, compile, and test them on the Ganache network. This makes it possible to design and test software fast and affordably, and iterate on and modify the code of smart contracts. Ganache is an essential tool for blockchain developers, as it allows them to test and debug their applications on a simulated blockchain network before deploying them on a live network. Here's a step-by-step guide on how to install and use Ganache for personal Ethereum blockchain development. Download the application for your operating system from the official Ganache website. Run the installation file after downloading it. Then install the application on your computer by adhering to the on-screen prompts. Ganache is available for Windows, Mac and Linux operating systems in all its versions. To create a new workspace, open the Ganache application and select New Workspace. Users can set up the network parameters for their unique Ethereum blockchain in the workspace settings, including the number of accounts, the gas limit, and the starting balance of each account. An Ethereum workspace is a set of settings and user accounts that establish the parameters for a customized Ethereum blockchain network built using Ganache. Developers may quickly set up a private Ethereum network for testing and development purposes using workspaces. After configuring the network settings, click Start to begin your own private Ethereum blockchain network. For each of the accounts you set up in the workspace settings, Ganache will generate a set of private keys. Then, copy the remote procedure call, RPC, server address from the top of the screen, as you will need this to connect your development tool. Using the RPC communication protocol, client software can invoke a server-side process from a distance. As a result, it is feasible to activate a procedure or function in another address space or process without the programmer worrying about the specifics of the underlying network transport or communication protocols. It enables programs to communicate with other systems on a network. It is necessary to link one's development tool, such as Truffle Suite, to the Ganache network to deploy and test smart contracts on the private Ethereum blockchain. To do so, follow these steps. After configuring the network, users can deploy and test their smart contracts on the private Ethereum blockchain. Using the Truffle command line interface, they can compile and deploy their contracts to the Ganache network. Once the contracts are deployed, the Truffle CLI can interact with them and test their functionality. It allows developers to interact with their smart contracts and the underlying blockchain network using various commands. Using the Truffle CLI, developers can automate the building and deployment of smart contracts, making it easier to develop and deploy dApps. When a smart contract is deployed to the mainnet, it must be submitted to the network, and a fee in cryptocurrency is paid to cover the cost of running the contract on the blockchain. When a contract is deployed, it becomes unchangeable and immutable. To guarantee that the smart contract works as intended and is secure, testing it properly before deployment is crucial. Step 1. Go to the directory where one wishes to build a project by opening the terminal or command prompt. Step 2. To start a new Truffle project, enter the following command. Truffle init is a command that initializes a new Truffle project with a basic directory structure and configuration files. Step 3. Under the contracts directory, add a new Solidity contract file. Here's an example of a simple contract that stores a string. The above code is a smart contract written in the Solidity programming language. One declared variable, a public string variable called myString, is present in the contract named myContract. Everybody on the blockchain can access the string variable, which is initialized to Hello World. With a tool like Ganache, this contract can be set up on a private blockchain or an Ethereum network. Once installed, it can be used to interact with transactions sent to its blockchain address. Step 4. A contract can be compiled by running the following command. Truffle compile is a command that compiles the